Hello, dear students. I'd like to invite you once again in this series of mathematics problem solving. Last time I taught you on formula transposition or transposition of formula, and today I will proceed with the other part of algebra. Now, I will start with BODMAS. BODMAS is an acronym of uh, B or for bracket open, then division, M for multiplication, then A addition, then S for subtraction. So this is the it's a formula for in order to guide us through mathematics operations. So it's a way how we can remember on operations of mathematics. So as I've told you, B stands for bracket open, BO, so it's a short form of BO. This one is bracket open. So if you have any mathematics operation, you should start with opening the bracket. Okay, secondly, we have D stands for division. So if you have the bracket and division, then bracket starts, then division, then M stands for multiplication, then A is addition, S is subtraction. So the order is as how I've written. So if you have an expression like this, should you have an expression like this, 4 plus 3a divided by 6a minus 3a minus 3. The first thing is you should start by opening the bracket. So the operation will start here. Okay, the operation will start here. Okay, so we start by the values in the bracket. After finishing this, then we follow with another step of division. Okay, so if there is multiplication, then we move to another step for multiplication, and if you don't have, it's okay, you can just skip. And the third part is addition. So if you want to have addition, it's you should start to operate before subtraction. At the end, it is subtraction. Okay, now for example, this I can do like this. Okay, now I can do like this. Okay, now this is 4a plus 3a, then divide by, since we start with bracket opening, then we start with by dealing with the values within the bracket. Now 6a minus 3a within the bracket, this one is 3a minus 3. Now we have already, now from this one we can remove these brackets because we have already okay, sorry, let me copy this. Therefore 4 plus 3a, then divided by 6a divided by 3a, it is 3a, then minus 3. Then the second operation is division. Of course, we have division here. We have a division here. This one, 3a minus divided by 3a. Okay. Therefore, this one will be equal to 4 plus 3a divided by 3a. It is 1. Then minus 3. Now the third operation is multiplication, but we don't have multiplication here. Then we skip. We move to another step with the addition. Of course, we have an addition here, which is 4 plus 1. Okay. Now this one, 4 plus 1 will be equal to 5. then minus 3. Now the last operation is subtraction, and here it is. Here it is. Now the answer, the end will be equal to 2. Sorry. Okay, like this, just like the right color. Now this one will be equal to 2. This is how we deal with BODMAS. Of course, my whole topic will not involve BODMAS, but at least I need you to understand what exactly we are going to do in algebra. And a lot of algebra terms will involve BODMAS operations. So we are going to have a lot of operations. So if you're not good on BODMAS, how to deal with these operations, or don't remember BODMAS, then it will be difficult for you to resolve these problems. But I've given you just a startup so that you can understand how you can solve mathematics operations with a good numbers of operations. Okay, now assume you have given this operation. Assume you have given this. Example number 1. Now assume you have given this operation, maybe 5x plus 2x minus 3y. Now find the solution of this. Okay, always follow the rules. Now we start with 2x minus 3y. It is impossible because they are these things are not the same, they are quite different. Okay, so we automatically will open the bracket. Okay, now 5x plus 2x, of course I'm copying here the question. Okay, now this one will be equal to 5x then plus 2x, because outside here there's 1, then 1 times 2x is 2x, then 1 times negative 3y, it is negative 3y. Therefore the answer will be equal to 5x plus 2x. Of course we start by adding, therefore 5x plus 2x is 7x, then minus 3y. This is the answer. Now assume you have another example here. Example number 2. Now I have told you to find the solution of this. Maybe you have m 2p minus q. Okay, sorry. Maybe you have 2p minus q, then minus m 3p plus 2q minus 5 mp minus mq minus mq. Now solution. Open the bracket first of all, which is the rule. You should start by opening the bracket. Now 2 m times 2p, it is 2 mp minus m times q is mq minus m times 3p is 3 mp minus the negative m times 2q positive. This one will be equal to 2 mq but negative, minus negative 5 times positive mp. This one is equal to negative 5 mp, then minus negative 5 times negative mq. This one is equal to positive 5 mq. Now arrange the alike terms. Of course I have 2 mp and 5 mp and 3 mp, the alike terms. Now 2 mp, this one, these alike terms, 5 mp, 3mp, and 2mp, 3mp negative, and the 5mp are like terms. And also we have mq and the negative mq and the 5mq also the same term. So I'm going to arrange them in that form. So 2mp minus 3mp plus 5mq. Oh, sorry. Yes, okay, plus the 5mp. Okay, in plus 5 mp. Okay, this is minus. This is minus. It is minus 5mp. Then minus this one, mq. Then minus 2mq, minus 2mq. Then plus 5mq. Now this one will be equal to 2mp minus 3mp minus 5mp. This one will be equal to 2 minus 3 is equal to negative 1. Negative 1 minus 5 is equal to negative 6mp. Then minus negative mq minus 2mq plus 5mq. This one will be equal to 2 positive 2mq. Okay, this is the final answer. So I hope at least you have understood something about the BODMAS. Okay, so we should start with opening the bracket, then division, multiplication, addition, then finally subtraction. So if you have given a kind of operation with such numbers of operation, please just follow the order as I mentioned before. Now I'd like to finalize by giving you the identities. You can have an expression, okay, and they can be asked not to identify whether it's an identity or not identity. What is an identity? An identity. An identity is an expression where the values of the left-hand side of the equal sign and the right-hand side of the equal sign are the same or they balance. For example, if you have this expression, maybe 2, example, you have this expression z, okay, this is z, then plus 1, this one is equal to z plus 2. So if this side, if an expression of the left-hand side is equal to an expression right-hand side, okay, if an expression of left-hand side is equal to an expression of right-hand side, then we can say an expression is an identity. And if not, we can prove that an expression is not an identity. Then how can we prove this? This can be proved by can just give a letter and a number, then you can prove. That's the first method. Or you can use another methods of proving it, but basically I'm just giving you this. Now let z is equal to 1. Now add z, the value of z to an expression above. Okay, now I'm going to have 2, z is 1, then plus 1, This one is equal to 2. Z is 1, then times 1 plus 2. 2, inside I'm going to have 2 is equal to 2 times 1, it is 2, then plus 2. Okay, 2 times 2 is 4, then it's equal to 4. Now, since the left hand side is equal to the right hand side, then this one is an identity. So you can prove like that. So this one is an identity. It is an identity since the left hand side is equal to the right, equal to the left hand side. So this one is an identity. Okay. Now consider another expression here. Assume you have this expression. Okay, maybe you have this expression. X squared. You need to prove whether this expression is an identity or not. Okay. Now assume you have x squared minus 1 is equal to x minus 1 then x plus 1. Now prove, is it an identity? Okay. Now x is equal to 1. You just choose any number, but I'm advising you to choose the smallest number so that it can be easier for you to make a faster computation. Okay. Now xc replace with 1, then for this one will be equal to 1 squared minus 1 is equal to x, which is 1 minus 1. Okay, and over here will be x, which is 1 plus 1. Okay, then 1 minus 1 is 0. Okay, 1 squared is 1, then minus 1 is equal to 1 minus 1, it is 0. Then 1 plus 1, it is 2. Okay, then 1 minus 1 is 0, is equal to 0 times 2, 0. Therefore, this is an identity because the left hand side is equal to the right hand side. So this one is also an identity. Okay. Now, assume you have this one. Assume you have this one. Assume you have this one. 2y plus 1. This one is equal to 2y plus 1. Prove if an expression is an identity. Now let y is equal to 1. Now this one will be equal to 2 times y, which is 1, then plus 1 is equal to 2y, which is 1, plus 1. Now this one will be equal to 2 times 1, it is 2, plus 1 is equal to 2, bracket, 1 plus 1 is 2. Now 2 plus 1 is 3, this one is equal to 2 times 2 is 4. Now since the right hand side is not equal to the right hand side, then this one is not an identity, since the left hand side is not equal to the right hand side. So you can be given an expression. So what you have to do is you can test by adding, by giving the values yes, you can provide with the numbers so that you can balance and see whether they are the same or not. Now let me give you a last example so that you can see how you can check these expressions, whether they are an entity or not. Now look at here. Assume you have you have, okay, maybe this one. Assume you have 4 AD minus 6 AC. This one is equal to 4. Sorry. This one is equal to A. bracket 4d minus 6c. Now check whether it's an identity or not. But we have letters, we have A, we have D, we have C, then we have D. Okay, now let A is equal to 1, showing that. Let C is equal to 2, and let D is equal to maybe 3. Now we need to plug these values in the expression. Okay, now solution, can do this by testing. Then 4 times A is 1 times D is 3 minus 6 times A, which is 1, times C, which is 2, is equal to A, which is 1, then 4 times D is 3, minus 6 times C is 2. This one will be equal to 4 times 1 times 3 is 12, minus 6 times 1 times 2 is 12. So this one is equal to 1 to the bracket. Then inside you're going to have, well, this will be equal to 4 times 3 is 12, then minus 6 times 2 is 12. There 12 minus 12 is 0. This one is equal to 12 minus 12 also is 0. Now you can see, now this one is an identity since the right hand side is equal to the left hand side. So this one is proved. Okay. Now I hope now you are able to work with BODMAS and in mathematical operations, and then you are also able to identify whether an expression is an identity or not. Now for today I'd like to end there, so see you next time. So in case you have any problem, I will provide you with an email so that you can share with me, so that you can also share with the other students, and then we can also solve the problems of mathematics in case of any problems you face. See you next time. Bye for today.